Hi everyone, I just want to do a little video going over these in case you need more help. Here is what you will be given on the test. This statement at the top, or a similar statement at the top, actually 3 similar statements at the top. It's a 3-piece question. If we close the door, then there is less noise. There is less noise, therefore we close the door. Remember those 3 dots are therefore, or in different types of mathematics, QED for quantum erat demonstratum. So we have P and Q. You don't have to write these out separately on the test. It's just what you need to know. I can go up here and actually just kind of put them up here. Like if we close the door, that we close the door is going to be P. There is less noise would be Q. This one here is still Q, right? And we close the door, that's actually P. So our first premise is that first sentence. If we close the door, you know what, I'm not going to write it out because it's right up there, but I am going to write it in symbols. If we close the door, so premise 1 would be if we close the door, since it's an if then, we're going to do P. If we close the door, then there is less noise. Premise number 2 is just Q. And then our conclusion is therefore we close the door, which is P. So now that I have this written, out symbolically, I can check it against the valid and invalid arguments table. So I'm looking for P goes to Q, and then Q, and then P. Okay, and so it looks like it's right down here, the fallacy of the converse. I have P goes to Q, Q, therefore P is a fallacy of the converse, right? And if we have a conditional, the only time that conditional is going to be false is if you're breaking your promise. So if we close the door, then there is less noise. So I'm promising you if we close the door, then there is less noise. There is less noise, therefore we have closed the door. You just can't guarantee that there's less noise because the door was closed.